Hi everyone, it's Coach Fred, and I'm today going to be going over polynomials when they're in factored form or intercept form. So we've been working with polynomials in standard form, and we learned about their the degree and their end behavior, and intervals of increase and decrease, and max and min. But just like quadratics and linear functions, we can have other equivalent forms. So we're going to write a polynomial in what I like to call factored form or intercept form. So you've seen these before because we did this with quadratics. So when we want to write something in factored form, we then write each x-intercept as a factor. So maybe something like this, x minus 2, x plus 4. Those are factors, and that would be a quadratic function. But when we make it a polynomial, I can add on and I can have more than 2 factors. But they are all linear. So when we write it in standard form, in factored form, these are all linear factors, okay? So I want you to recall that the zeros of a function are also called the solutions or the roots of a function. When we're finding the zeros of a polynomial, it's easiest when the function is in intercept form. All we need to do then is set each factor equal to 0 and solve. That's using the zero product property, the ZPP. If it's not in intercept form, then put it in intercept form by factoring. Now we are going to look at other ways. If it's not factorable, I'm going to first send you to your graphing calculator or to Desmos to take a look at what the graph is doing, because then you can see it probably has irrational roots. All right, now the next thing I want to talk about is looking at the degree when it's in factored form. So here we have a polynomial in factored form. We want to find the zeros and we want to state the degree of the polynomial. So remember, in standard form, we take the highest degree, but in factored form, we actually have to add the degrees. So each one of these factors here has a degree 1. So this is a degree 3 polynomial. Now, I also want to look at the leading coefficient. You have to look carefully. If x was multiplied by x was multiplied by x, that's going to be the x cubed that you get. So that's going to end up being the leading coefficient, which would be positive. So I have a leading coefficient that's positive. All right, so I want us to think about that for a second. Think about what the end behavior would look like. All right, so how do we find the zeros? We set each factor equal to 0. So in this case, we're going to have x equals 0, x equals -3, and x equals 1. Now remember, those factors lead us to the zeros, which are the x-intercepts. So 0, 0, -3, 0, and 1, 0. Now you're going to see them written both ways. I prefer them as coordinate points, but sometimes it might ask you for, to find the x-intercept or find the x-intercept, and it'll just ask for x equals 0. All right, so let's determine the end behavior. It's a degree 3 polynomial. The leading coefficient is positive, so it's going to be down up. Something like that. All right, now we don't know what's happening in the middle. We just know that the end behavior is down up. Okay, but we do know our zeros. So I'm going to plot it. I have a 0, I have a -3, and I have a 1. And I know that my end behavior is down, up. So I kind of draw those arrows in, then I see what's happening. So, and if I really want to look carefully, I can also see that my y-intercept is when I set x equal to 0. So if I set x equal to 0, this is all going to be 0. So my y-intercept is 0, 0 as well. All right, so now I'm going to graph. Now remember, this is a sketch of the graph. So I'm going to go up through here. I'm going to turn around somewhere. I'm going to go down here. And okay. In class the other day, I was really pleased to see many of you were wondering, well, how high does it go here? And how high does it go here? Or how low does it go here? And remember, we would call this a relative maximum or a local max and a local min. Well, we don't really know if we're sketching. So what could we do? Well, we could plug in points. It is a function, so we could take some x's, inputs, and plug them in and find the outputs. But for now, let's just leave it like that. Or we could also graph it on our calculator and look. But let's leave it like that for now, because right now I just want you to get used to looking for the zeros. All right, but there's some other things that happen at that function, and one of the things is something called multiplicity. Multiplicity, so the degree of the factor tells me kind of what's happening at the graph. So multiplicity in factored form is the degree the linear factor is raised to. Now, I started to bring this idea up in class the other day to see if you kind of saw some patterns, but I'm going to clarify them for you. So first of all, what determines how many x-intercepts the graph of a polynomial has? Well, how many factors it has, the number of factors. However, the thing we have to remember is that there could be repeated factors. And so when there's repeated factors, some interesting things happen at those locations on the x-intercept. Okay, what determines the graph's behavior at each x-intercept? You guessed it, the multiplicity. All right, so we're going to be looking at the multiplicity three ways. We're going to be looking at a multiplicity of 1, which means that each factor has a degree 1. We're going to look at a multiplicity of 2 when a factor has a degree 2, and a multiplicity of 3 when a factor has a degree 3. All right, so let's look at these three examples. I'm actually going to go to Desmos to do that. So here's the first example. This is x times x plus 1. Let me move this over a little bit so you can see it. X times x minus 1. So you can see it's got a 0 at 0 and 1. And you might see it just goes nicely, smoothly through those x-intercepts. And that's because when a factor has a multiplicity of 1, it goes straight through the point. So we would say that, first I'm going to sketch it. So 0 and 1, it's just going to go through it. So when it has a multiplicity of 1, it goes through the x-intercept. Okay, goes straight through it, nice and clean. Okay, all right, let's look at a multiplicity of 2. So let's go back to Desmos. Let me close that one. Let me turn this one on. All right, so here we've got a couple of things. So look at the factor of -1 right here. It's got a multiplicity of 1, so it's going nicely straight through. But the factor of 3 has a degree 2, which, look what happens. It turns around right at the intercept. We call that a bounce. It bounces at the intercept. Now, that should actually kind of make some sense to you because x minus 3 squared is the square of a binomial, which means that it's a perfect square trinomial if I was just looking at that piece of the graph. And we learned that perfect square trinomials only have one x-intercept, and their x-intercept is the vertex. So you can see if I'm only looking at this part of the graph, it looks like a parabola with one x-intercept. Okay, so let's clarify that. So first, let's draw this. We had a -1 and 1, 2, 3. And so it went right through, actually, it came up, sorry, it went right through, it turned around, and then it bounced there. Okay, so we call this multiplicity of 2, we call it a bounce. Okay? And the reason it has that bounce is because it has repeated roots, repeated zeros at 3. Okay, the last one we're going to talk about is the multiplicity of 3. Multiplicity of 3 means that it has it's got repeated zeros 3 times. And I call it a squiggle, but let's look at it on Desmos. Sure, there's a better name for it, but that's what I call it. I call it a squiggle. So you can see that through -2, it's going straight through. So at that -2 point, graph's going straight through. But at 3, look, it's kind of squiggling through. It looks cubic, actually, and that's because it is a degree 3, so it's squiggling through that x-intercept. All right, so let's try and draw that, because that's actually a hard one to draw. All right, so here we've got an x-intercept of -2, and 1, 2, 3, and it's a degree 4, so it's up, up. And so I'm going to go right through 2. I'm going to go down, and I'm going to turn around, and I'm going to squiggle through 3. And so those are our multiplicities. So again, we have a multiplicity of 1. It goes straight through the point. We have a multiplicity of 2, a factor that's going to bounce at that point. And a multiplicity of 3 is going to squiggle through that point. All right, let's try one. All right, on your notes, I'd like you to change it. I'd like you to change the factor of x plus 2 to a power of 2 and the x minus 3 to a power of 3. All right, so we're going to sketch this polynomial. Again, we're just going to sketch it based on its degree, its intercepts, and its multiplicity. All right, so this would be a degree 6 polynomial because remember, I add the degrees, okay? All right, the leading coefficient would be positive because all of those x's are positive. All right, it's got zeros or x-intercepts at 0, 0, -2, 0, and 3, 0. Okay, y-intercept, looks like that y-intercept is also going to be 0, 0 because if I plug in x here, if I make that 0, it's going to make the entire polynomial 0, 0. Okay, so how do I want you to write the multiplicities? So I want you to take all of your x-intercepts. So we have an x equals 0, we have an x equals -2, and we have an x equals 3. And I want you to label their multiplicities. So x equals 0 has got a multiplicity of 1, so it's going to go straight through. -2's got a multiplicity of 2, so it's going to bounce. This one's got them all in it. And x equals 3 is going to have a multiplicity of 3, so it's going to squiggle. So we're going to do our best. Oops, squiggle. We're going to do our best to get this graphed properly. Okay, so we know it's up, up. And we've got a root at -2, a root at 0, and a root at 3. And it's up, up. So right above those, I'm going to put my up, ups. Okay? All right, so my end behavior is up, up. All right, so I'm going to go through. Actually, I'm going to bounce at -2. I'm going to turn around. I'm going to go straight through 0. And then I'm going to turn around. And I'm going to squiggle through 3. Maybe I could have done that a little better. And there's a quick sketch of the polynomial in factored form or intercept form and using multiplicities. Okay, we're going to be practicing this tomorrow, actually Monday in class. So hopefully that was a helpful video. Have a great day.